As decision making is so important in all programming languages, doing it in Java is really essential and really kind of along the lines very similar to most languages. Logic constructs start with the basic idea of a decision being binary, yes or no, allow or disallow, one or the other. And so that's the foundations of the Java if then else statement. Um, Now, binary decisions normally branch off that if not red, then black. Well, what about green? What about purple? What about yellow? There's a lot of different options there. And that's where the switch statement comes in, is when I have, instead of just two choices, one of a bunch of them. I'm not infinitely big, but in theory it could be pretty darn big. But discrete choices, that's where the switch statement comes in. So we start with this idea of true or false, yes or no, on or off, and then we expand out to choices from there, and which really is just a natural extension, but we can save some coding time. We're going to start off with this idea of the if statement, though. The if statement is that basic choice of to do or not to do. At the very basic if statement, it's either yes or no, good or bad, do or don't do. And that's based off of the Java Boolean type, which is either a true or a false. And lowercase true, lowercase false. That's literally the code you'd be typing in for that. Java does not equate true and false to ones and zeros, as originally C did and some languages do. It's a decision that's completely logical. It's not truly coming down to the hardware representation of that. So we can have a decision such as if we are ready to go to the airport. Yes or no? Are you ready or not? Or I can break down that into conditions that mean the same thing. If our stuff is packed and the taxi is here, or we are driving ourselves. So that's a series of questions that say, are you ready to go to the airport or not? That's the foundation of the if statement. Now, the basic Java if statement has very simply the word if, we can see here, and then a decision that's being made, a Boolean answer of either true or false. So I can say if I should print, it could be true or it could be false. And then I do something like the output is, and then if I should print, then I print. Printing the results is true. If I shouldn't print, I do not print that, and then ask the question, did it print? So when the output is true, you'd see on the box over here on the right in gray, the output is printing, the result is true, did it print? When it's false, it just says the output is, did it print? It skips that code. Now, the reason it skips that code is because of the curly brackets. It's really essential to have opening and closing, matching curly brackets, ideally with this white space inside of here to show which code is being aligned. Now, if you ever program Python, either have or do it in the future, it doesn't use curly brackets. It actually requires the white space syntactically. In Java, it doesn't require you to indent and put the tab or the 4 characters or whatever you do there. It can be any sloppiness out there, but it is essential for logical, human reading, me thinking, remembering, understanding, I think, to have both the curly brackets and to do the spacing. Why make my job easier? Why not visually make it really obvious here? So that's my recommendation to you, is do exactly like you see here. Use the curly brackets and whatnot. Now, I'll tell you, it's allowed inside there not to do the curly brackets. So everything inside the curly brackets except true, I could write the code and it would compile, it would be valid without those curly brackets. The rule at that point is the first line of code after the curly bracket is what gets executed. And so those curly brackets, without being set of there, changes the results dramatically. So in this case, what ends up happening is it says the result of true is, the output is, the result is true, did it print? I'm sorry, that's the result when it's false. If it's true, it would say exactly what we said before. Printing, the result is true, did it print? When it's false, it would say printing, would not say printing. It would say the output is, as you can see right here, the result is true, did it print? So that's confusing. It looks like these lines should be grouped because of the indentation, but without the curly brackets, it's not. So the rule of style is in Java, always use curly brackets. The other thing I'll point out here is if you put a semicolon which does not belong at the end of an if statement. What it says to Java is, if I should print semicolon, the next line is do nothing, and then basically the if statement is useless. It always does nothing, and these lines always print. So that's why you always want to use curly brackets, and you never put a semicolon after an if statement. So coming back to the core syntax that we're seeing here, we have the if statement and parentheses. Inside of the parentheses is a decision that must result in a value of either a true or false, a single Boolean value. We will see you can add a else statement to this, where the else statement allows you to have an alternative. If it's not true, then do this other thing. And we'll see that behavior in a second. So if the decision is not true, then I go to the else to jump to a false. I can also use the term else and if, which gives me another option inside of there. We'll see that here in a second as well. But the else by itself is the final if things are, we'll get back to that rule in a second, but if nothing else is true there. But jumping ahead a little bit, but I wanted to show you this core syntax statement right here. Just what belongs here is the word if, the decision here, a Boolean inside of parentheses, and then curly brackets. That's really important here. So that decision can be any code that results in a single Boolean. You can call a method there. You can have some condition and operator such as and, or, not, the short circuit and or the complement inside of there works. There's all sorts of things you can do inside of there. So as we said, you can say if I should print and the printer is on and it's a sunny day, then print. Or I can say if I like you or I owe you money, then do this work. So any logic can go inside of there as long as it results in a single Boolean using all these operators and whatnot. It has to be a single answer to come back. So the else clause, as we just mentioned, allows us to say more than just should I do something or not. It's basically saying if I should print, then I do one thing, else I do a different thing. So in this case, I can say if the output is I should print, yeah, else no. And then you can say which one printed. So if the Boolean comes in as true, it says the result is true. If the input comes in as false, then it goes to the else branch. This is probably more common than just a straight if statement. Typically I say if the user has entered a value, then save the value. Else, go back to the user and say you must enter a value now. That basic validation is the most common thing you'll probably write in code. You could say, if I have enough money, then complete the payment. Else, charge you more money for not having the payment because you didn't have any money to begin with, and the bank makes money. Again, that's the type of logic you would see in an if then else statement. But sometimes you have alternatives. You could say, if the data is ready at this point, and I can say the data is ready, else an error occurred, and we can say something bad happened. Now, that's a trade-off inside of there. So you can say, if there's enough money, make the payment. Else, if there is a account tied to this account, which allows you to do a overdraft, a savings account or something like that, then pull the money from the savings account and then complete the transaction. So that's the next level. The else if statement gives me an alternative. The else if only occurs if the first one isn't true. So if the data is ready, then the else if does not ever execute. What happens in that case is, continue on. If data is ready, it says the output is data is ready, which printed. It skips an error has occurred. So the data could be ready and an error occurred, but since the data was ready, that's what happens. If instead the data was not ready and an error occurred, we could say something bad happened. So that's the important thing. It's not keep going. When you see this if statement and you see an else that comes after it, after the if executes, it jumps all the way back down to the end of the final if then else statement, the branching and everything else that happens inside of there. And this is important to understand because I can actually have the situation where neither of them are true. The data is not ready and an error didn't occur, so neither of them could possibly print. I could skip by both of those situations. Now, we can also continue to add any amount of if else if statements. So I can say if the data is ready, else if an error occurred, else if we're supposed to keep waiting, else if it's not Christmas yet, else if I just like sitting here wasting time. And then, after all that, I can use a final else branch, which says if none of those conditions are true, then this is what happens. So I can say, if today is Monday, then go to work. Else if today is Tuesday, make your way to work. Else if it's Wednesday, hump day, go to work. Else if it's Thursday, you're almost done with the week, I guess go to work. Else if it's Friday, the end of the week, go to work. Else it's a weekend. So you can see I can do something different for each of those alternatives. And then anything else, in this case Saturday, Sunday, I can have one alternative. And so if we look at the execution of this code here, if data ready is true, the output is data is ready. And then it jumps past the other two to the end, which one printed. If data ready is false, but an error occurred is true, then we print something bad happened and then jump to which is printed. If neither of those is true, if the data is not ready and the error didn't occur, then we always do what the else branch says. All right, that's the foundations of the if then else statement. The trick to using these is to come across some need in code, come across some logic that you have to implement, execute, and then go try it out. The syntax isn't too bad as long as you match up your curly brackets and you remember you don't have semicolons. You notice every time you say if or else if or else, there's no semicolon at the end of that line, but there is curly brackets. I like the curly bracket on the next line. That's what you can see from all of my examples. Your default in most of the tools is to put the curly bracket up on the same line as the if or the else if statement. You can do it either way, whatever you're more comfortable with. I like to line up the top curly bracket with the bottom curly bracket. I think it makes it much more readable. I can see that structure much easier. But you could also train your mind to line if with the end curly bracket, and it'll work itself out. If you want to, you can actually change that configuration in the tool. I'll show that in some other demo when I'm sharing my screen, possibly. But you basically go up to the options and look at the code formatter, and it'll let you do that. And you can look that up. If you don't want to find my video, go Google it. It's pretty easy in whichever tool you're using. So that's the key to writing good if statements, getting your syntax right, aligned, and then worry about the logic. Not all logic works out this simply. Not all logic makes this much sense to just jump at it and go. But that's where testing comes in. Try it out, see if it does what you want to. If not, tweak it. You might need to change your conditions. You might need to switch around. And by the way, it doesn't matter what the else and if else is. Depending on your code, you could rearrange these things in a number of different ways and it'd still be totally valid. So it's okay to play with this stuff. So go do that. Have some fun with it. And then jump into your assignment and see if you can make the rest of the stuff come together.